Welcome back to Chapter 6. Well, this is it. We're talking about quadratic equations to wrap up Chapter 6. And here we go. Good to have you back again. We've got several different things that you should have picked up in Algebra 1. We're going to review all these things. And if you need some more practice, just let me know and I can get you some worksheets. In the meantime, let's take a look at what's going on here. First of all, you should be able to multiply two binomials using the FOIL method. A lot of you are familiar with this. First, first, outside, inside, and last. That's how you multiply the binomials. The binomial is an algebraic expression that has two terms, only two terms. If it has more than that, we're talking about special cases. But there's so many binomials, that's why we spend a little bit of time on it. So here's some examples. And let's see if x plus 3. Notice they're separated by a plus or a minus. Two terms, the x and the 3. That's what makes it a binomial. Next, x plus 4, 3x plus 4, 5x minus 3. You get the idea? FOIL method. First, outside, inside, last. Now you don't have to do them that way, but it's an easy way to remember it. Aluminum foil. So here's an example we can use. So we want the product of these two binomials. First, x times x, x squared. Outside, x times 4 is 4x. Inside, 3 times x, 3x. And the last one, 3 times 4 plus 12. Now the two inside terms, notice, are typically, not always, but typically the same type of term or similar terms. So your final answer is x squared plus 7x plus 12, since you can add the 4x and the 3x. There you go, a little bit of a summary. And there's your final result. Next, a trinomial. Well, if a binomial has two terms, trinomial has 3 terms. Now it says you can use the FOIL method to multiply two binomials. What you obtain is typically a trinomial. Not always, but in the easier cases, yes, trinomial. So two binomials, and you end up with the trinomial. Now what we want to do quite often is not only be able to multiply them together, but also take them backwards too. Keep that in mind. Here's the trinomial form, where these two middle terms were added together, and there's the factored form. Sometimes we want to go this way, sometimes we want to go that way, depending on what we're doing. Factoring means you're taking the FOIL backwards. And by the way, I'm not going to mention it in this video, but there's something for factoring that expression. It's called the AC method. Make sure you ask about that in class, and I'll explain it. Next, so how do you factor something that has x squared plus bx plus c? Well, first thing you do is, since you know that x squared you get by multiplying x times x, when you're factoring, you put the x's in first. If it's 1x squared, it's got to be an x and an x. Second, look at this term out here, the c, the constant term. how many ways can you write C as the product of two different terms? Well, or the same of two terms. Next, check these combinations to see which one ends up giving you the bx, the term in the middle. We're going to use an example, don't worry. And then when you think you've got these two pieces, these two binomials together, you think they're right, multiply them out to make sure you get the original trinomial. If you do that, then this part was correct. If none of those tries that you get, if none of these combinations that you put in the first and second parts of the last one, then if you can't factor it, it's called prime, just like a regular prime number. 7 can only be multiplied by 1 and 7, or factored as 1 and 7. So here's an example we can use for a practice. So first of all, we've got the 1x squared. The only way we can get that 1x squared is by having an x here and an x there. The only way. So you can put that in ink if you want to, provided it can be factored. And then you take the 8. Make a list. How could you get an 8? Well, it could be 1 times 8, or it could be 2 times 4. Those are the only ways. Now, take a look at both of those, because you want to end up with a 6x. Well, the 1 and the 8 won't give you 6 no matter what you do. The 2 and 4, yes. So 6 goes there, 8 goes there. Because this is a plus, this tells you that both of these signs will be either plus or minus. Because this is a plus here, then both of these are going to be pluses instead of both minuses. Put the x in for the beginning of both. List the factors of the constant, 8 in this case. And try the combinations. Take a look at these factors that you've got for 8. See which one gives you the right middle term. There are some possibilities, and the only one that gives you 6x is this one. So the 4 and the 2 are the ones that you'll use for the factor. And there's the correct one. Last of all, multiply these two together and make sure you get the x squared plus 6x plus 8. Another one to try. I guess we can scratch this off. All right, so you have 3x squared. How can you get 3x squared? First of all, to get the x squared, there has to be an x term here and an x term here. However, x times x only gives you x squared, and you need a 3x squared. Fortunately, the 3 is a prime, and the only way you can do that is 3 here and a 1 there, or vice versa. It doesn't make any difference. Now, take that 28. How can you factor 28? 1 and 28 is a possibility. 2 and 14. 3 doesn't work. 4 and 7 works, and that's it. Now, it's time to experiment. Now, this takes some trial and error, so you can try putting a 1 there and a 28 there and see if it works. By the way, this plus right here means these two signs are going to have to be the same, both pluses or both minuses. However, this one says we know which it is. They have to be both minuses. We can put those in if it's factorable. Now, you try putting a 1 here and a 28 there and see if you get that 20x. Well, As a matter of fact, it doesn't work. So erase those. Try it the opposite way. Put 28 here and 1 there. See if that works. Gives you 28x and 23x. That doesn't give you the 20. So we can scratch this off entirely. Erase those. 2 and 14. All right, so you try 2 here, 14 there, and cross your fingers. All right, 2 times x is 2x. 14 times 3 is 42. That won't give us a 20x. So we'll swap them. Put 14 here and 2 there and see how it works. 14 times x is 14x. 2 times 3 is 6x. Add the 2 together. Bingo, we've got it. So put the 14 here. Put the 2 there. Double check. See if you get 3x squared minus 20x plus 28. Here's a review of all that. So factorizations. And here are some trials you can attempt. This is the one that actually works. None of these works. There's never 2 possibilities. Only one is going to work. So you have to keep trying with those factors of C to find out which one works. So we've got it. Multiply it. And this is good. So check. It's good. Next. We've been talking about quadratic expressions. Now we're going to talk about quadratic equations. And they look like this. Notice that you've got a quadratic term. That means x is squared. You've got a linear term, which means it's x to the first power. And you've got a constant out here with the equal sign. And this is very important. That equals 0. That's a quadratic equation. Now pick 3 of your favorite numbers. Maybe 7x squared plus 4x minus 19 equals 0. Just put numbers in for A, B, and C. Plus or minus. It's up to you. That makes a quadratic equation. Quadratic because of this, and all the exponents are integers. The x squared is the highest term, so you've got a quadratic equation. Second, once you know what a quadratic equation is, how do we solve it? Well, we're going to use the zero factor principle. That means that if I multiply 2 mystery numbers together, and I end up with 0, that's what zero product means. If I multiply 2 mystery numbers together, get 0, what we do know is one of those mystery numbers is 0. We don't know if it's this one. We don't know if it's this one. But one of those is 0. And if one of those is 0, we can set this equal to 0, this equal to 0. One of those at least will have to be a solution to that quadratic equation. Here's another way of putting it. We're multiplying A times B. A and B are numbers. You get 0, and one of them has to be 0. We don't know which one. So let's take a look at solving a quadratic equation by factoring. First of all, remember I said that 0 is important. The zero factor property only works if you have a 0 over here. If this were a 10, everything's off. You can't do that. Because if there's a 10, there's lots of ways of getting a 10. course, 1 and 10, 2 and 5. You think that's it, right? Not quite. 2.5 times 4 gives you 10 also. 1.25 times 8 gives you 10. You get the point. There are lots of ways of getting 10. So having a 10 out here isn't going to work. The only thing that's going to work out here is if you get a 0 on one side of the equation. That's the only way you can use the zero product property. So once you've got that 0, next thing you want to do is factor. Once you've got it factored, use the zero product principle, saying each of the factors equal to 0. And you'll see an example coming up right here. Solve the equations that you get from this, and then check them in the original equation. Now this is very important. Go back to where you actually began and check your solutions in there. Make sure they work in the place where you started. That might be a word problem. You might have to go back to the sentence or the paragraph and make sure those numbers work. Okay, here's a quadratic equation for us to play with. Well, first of all, notice there's no 0 over here. That's not good. So we'll have to subtract 35 from both sides. Now we're ready to go. We have to have the 0. And just as a reminder, in this case, 0 is your friend. Next, we're going to factor the left-hand side. Well, fortunately, it's only x squared, so these two terms, these initial terms have to both be 1x's. Next, we need to get 35. And 35 has to be a product of the first last term and the second last term. So we'll make a list. How can we factor 35? Well, I always start at the beginning, just in case, to make sure I don't miss anything. 1 times 35, 2, no, 3, no, 4, no, 5, yes. 5 times 35, and that's the last one. Because 7 times 5 is the same thing as 5 times 7. Now, let's take a look over here. What can we learn there? Well, first of all, this minus sign right here, if you take it, put your eyeball on this one, this says when we multiplied two numbers together, we got a negative answer. That means these two numbers have to be opposite signs. And that means when we add those two terms together, we're going to be subtracting them, and we end up with a minus 2x. So which one of these gives us a minus 2 if we subtract them? This gives us 34. This gives us 2, yes. Now, so we know we've got a 3 and a 5 and a 7. When we add those together with different signs, we end up with minus 2x. So the bigger number had to be negative because of that minus 2x. So this would be a negative 7, and of course a positive x. So negative 7 plus 5, and there you go. You've got it factored. Next, just to make sure, maybe off to the side or wherever you feel comfortable doing it, multiply those two together. Make sure you get the x squared minus 2x minus 35. Okay, got that? We're in good shape. Now, once you've got it factored, there's the factored version. Take each one of those factors and set it equal to 0. So x minus 7 equals 0. So from this quadratic equation, we end up with two equations. X minus 7 equals 0, x plus 5 equals 0. Remember, two things multiplied together give us 0. One of these has to be the 0. We don't know which one, so we set both of them equal to 0. Solve this equation. It tells us x equals 7. Solve this equation. X equals -5. Well, we've got two answers. We've got 7 and -5. If they're asking you for a solution set, the solution set includes 7 and -5, but we forgot something. We need to check that. Make sure if you put a 7 in here, this is true. And then make sure when you put a -5 in there, that's true. That's the only way you can be sure that these are both solutions. So make sure you check it. Now there is something you can do on your calculator that can help you a little bit. So I'm going to give you one example. I'm going to take the 7 with your TI-84, type in the 7, that's easy. Hit the store key on the bottom left side. It's going to look like this, an arrow. Then type in the X key, which is this weird thing that has X, T, theta, and what looks like an N. It'll show up on your calculator as an X. When you hit enter, it's going to tell you that you put in a 7. Well, that's not much help, but what does help is what you're going to do next. You're going to take what's on the left side of the equation, and you're going to go to your calculator again, type in x squared minus 2x. What should you get as an answer? We should get this 35. If you get a 35 here, then this 7 checks out and it's good. Next, you go back up here, put the -5 into x, type this back in again. Again, you should get a 35. If you get a 35 that time, then this one is good as well. A quick way to double check. Now, why would you do that? Because this one's pretty easy. Well, it could be a more difficult problem. Say you ended up with, and this would be in a different question, suppose you ended up with x equals -3.77 and you wanted to check it. That would be a lot more difficult. With this trick, if you want to call it that, with the calculator, you can check -3.77 very easily. Make sure the left side of the equation and the right side of the equation give you the same answer. So there's an easy way to check. All right, check the solutions. Moving along, there are your two checks. This is doing it manually, which is a good idea. If you're not very good with arithmetic, then take these two and check both of them. If you need a little bit of a review with your arithmetic, do this, please. If you're already quite good, then you can use the calculator to double check your solutions. Last of all, you should take note of this. If you put a number in and the solution is false in the original equation, then that solution is extraneous. That means it's one that is not useful to you. Next, sometimes it's hard, very hard, to factor a quadratic equation. When that's the case, then the quadratic formula is your biggest friend. What's the quadratic formula? There you go. X equals, because you're looking for x. And these are the a, b, and C that you're going to put in the quadratic formula. Put the B value here and here. Put the A value here and the C value here. Make sure you don't make any silly mistakes. And that'll give you one solution when you use the plus sign. You get a second solution when you use the minus sign. The quadratic formula is all really quadratic formulas. But writing it like this, let me get rid of those. Writing it like this allows you to write just one formula, but it's actually two. But it's very efficient as far as writing is concerned. You might make a quick notice that B equals a plus or minus here. Don't forget, you're always going to get two answers. Sometimes they might be the same, but two answers because it's quadratic. All right, so how to use this quadratic formula? Well, here's a quadratic equation to play with. Notice that A is 2, B is 9, and C is -5. So you bring out your quadratic formula, write it down first maybe. X equals minus B plus or minus, because we've got two formulas. B squared minus 4AC all over 2A. Make sure you extend this line the whole way out here. If I ask you on a quiz, can you write this? Make sure you got it exactly as it shows here. So here's A, B, and C. All you need to do is put them in very carefully. Follow your order of operations. Here are the numbers put in. Did some of the multiplication inside the radical and in the denominator. Add the 81 and the 40 to get 121. The square root of 121 is 11. Here are your two answers. Split them up at this point. Write this down with a plus here and get the answer. Write it down with a minus here and work out the answer. Two answers. Now how about this one? On the previous one, notice that we already had the 0. You must have the 0 before you can use the quadratic formula. You might rush into saying A is 2, B is 4, C is 1. Incorrect. No. You first have to get 0 on the right side, or whichever side you want. Once you switch them to the right, here's the equation you can use with the quadratic formula, or to factor, you have to have that 0. Pick up the 2, -4, -1. Notice these are not the numbers you saw up here because you didn't have the 0 yet. And put those in the quadratic formula down here at the end. When you get to this point, write it down with a plus, write it down with a minus, and you got your two answers. If this number inside is negative, then you won't have any solutions at all. No real solutions at least. And that means no solution. If you want the solution set, what is it? It's empty because there are no solutions. Now here's one that I found very interesting. Here's the normal systolic blood pressure measured in millimeters of mercury. For you chemistry people, that would be Hg. And for men, you have this formula right here. And you've got a graph on the right, making it easy. It says, find the age to the nearest year for a man whose systolic blood pressure is 125. So, okay, where's the man? This line right here is for the man. So, start at either end of this curve and find where it has a height of about 125, somewhere around here. It says find the age of someone that has a 125 systolic. Remember, that's the high reading. Systolic is the high reading. Diastolic, or something like that, is the low reading. Now, all you have to do is go down like this, and this person is somewhere around 30. However, let's get the exact amount. So you take this formula, and it says for pressure 125. So what you want to do is put that 125 in where the P is. So you got 125 equals 0.006 A squared minus 0.02 A plus 120. Now, if you want to, you can just make those A's X's. It's up to you, really, because you're just finding the value of a variable. You've got a quadratic. Notice there's a 125 on one side. It needs to be a 0. So you have to subtract 125 from both sides before you can use the quadratic formula or before you can factor. So, how does this work? Well, this is how it works. Change it so you've got the 0. So you should end up with this formula. Scratch that. So you get A, B, and C. Put those in the quadratic formula. Just a gentle reminder. Minus B plus or minus square root of B squared minus 4AC all over 2A. Put those numbers in and you're in business. Now, what happened in this one? Well, some of these parts you're going to have to use your calculator, frankly. Notice that you've got the square root of 0.1204. No one's likely to do that in their head or on paper, so you need to use your calculator. What you end up with is this, which when you use the calculator, you get A is negative 27. Well, you can't have a person aged negative 27 years old. But the plus does give you a reasonable result, 31. You can't be a negative 27 years old, but you can be 31. So our answer, which we saw from the graph was about 30, is actually 31. Remember, this is the average age, so it's going to vary from person to person. Now, if you want to find out how old I am, try this. My normal reading is about 110. So try using that. That's millimeters of mercury. See how old that should make it. Well, while you're doing that, I'm going to close this off. It's been nice seeing you again. See you in class, and I'll answer all your questions. Okay, take care of yourself.